we're going to talk about the basics of drills. We're not going to talk about super long drills. We're not going to talk about micro drills. We're only going to talk about the basics for drills. So somebody's going to walk in and they're going to say, hey, I need a 1/4 inch drill. You're like, great, I've already got some of the information I need. It's a 1/4 inch diameter. Next thing you need to know is if it's stubby or jobber. You always need to know this. Sometimes the customer won't tell you, and they'll just say how deep they're going, and I'll get back to that in a second. But a stub length drill is going to be 3 times the diameter in cutting flute length. A jobber length drill is going to be 5 times diameter in cutting flute length. Standard industry terms. So let's say your customer doesn't know if they want a stub drill or a jobber drill. They just like, I don't know, I'm going an inch deep. So you're gonna, you can do some basic math, right? On a 1/4 inch drill, if you multiply that by 5 for a jobber drill, it's 1 1/4 inches deep. So you would just go with a 5 times diameter drill. You want to go with the shortest possible while also leaving some room for chip evacuation, usually like at least 1/8 of an inch. Deeper than they're going for chip evacuation. So for example, they're going 750 deep. You technically could get away with using a 3 times diameter drill with the exactly 750 length cut, but you'd actually probably get better performance out of the longer drill in this case, just because you'd have more room to evacuate the chips out of the hole. So next question, cobalt or carbide? I'm going to talk more about carbide, but we'll briefly go over cobalt. Cobalt is the cheaper of the two. Not as high performance generally. It's more flexible, less rigid, which is good and bad. A cobalt drill, like a 1/2 inch cobalt drill is going to be like $7, and a 1/2 inch carbide drill is going to be like $45 for something decent, right? So cobalt's going to be way cheaper. It tends to come in packages. I'm going to stop talking about cobalt. Carbide drill. Now, the next thing you're going to want to know is what material they're cutting. If they're cutting something soft, like aluminum, you don't want any coating on the drill. You want it as sharp as possible. Now, if they're cutting something hard, like stainless steel, you definitely do want coating. Most high-performance drills come with coating. It's actually kind of harder to find them without it. But, a Thailand or Alton, a tin if you're really desperate, but tin sucks. Standard coating for a drill. So, at this point, we know our customer wants a 1/4 inch jobber length carbide drill. And you're really almost done. The only thing left is that some high-performance drills come with through-spindle coolant. Through-spindle coolant is basically, there's little holes at the back of the drill that go all the way to the tip of the drill. And if you've got a high-pressure system, you can flood those holes with coolant from your machine, and it will help push the material you already cut out of the hole so that you aren't cutting it again. Cutting things again is the worst thing you could ever do. Genuinely, like, it's the death of tools. So you never want to be cutting things again. If you've got a machine that has through-spindle coolant, you almost always want to be using it. It's just good. But our customers soup, they don't need that, so you're actually, like, you're done. They want a 1/4 inch jobber length carbide drill coated for coated for stainless steel. And that's it. Like, that's all you need to know about drills 99% of the time.